Hello, we are Raiders Code. Welcome to our Engineering 1330 final group project. Our project is over the red wine quality project. My name is Trent.
I'm Leo, and I'm Abhinav Gupta. So this is our project. We started off by setting all of our required libraries. We printed out the quality check, new quality check based on the data frame. So it will print out the quality if it's 6, if it's above 6, it will print out it's good. It will print out the 1 which is good, and if it's not, it's 0. It will print out 0, which is bad. We also print out the basic statistical measure of the data frame, red wine. We also did some missing values on the data frame. So as you can see, there is no missing values on the. As you can see, it says 0, which means that we have no missing values in the data frame. So this is the graphical representation of the parameters of the various parameters using like pair plot. So we use the code scatter plot of red. So that's what the graphical looks like. So we copied the data set from 0 to 10. So that's what the data for that would look like. That's the quality check for our count plot. Okay, that's the calculating the correlation between all the parameters of data frame. We use the correlation equals wine quality.core. So we use that's all of our data. And that's the heat map of our correlation coefficient. Yeah, so the 1 is good, the 0 is bad. Yeah. After doing the data analysis, we move on to implement our grid logistic regression code. So for that, we first converted all our parameters into their standard units. We just subtracted the input value from their mean and divided it by standard deviation. Then we shuffle our data frame. We randomly shuffle our data frame using random function. So for this, we use the length of wine quality x is 0, which means we shuffle against rows. So now we have total 1,119 rows for training set and 480 sets for testing set. Printed first 5 rows for the training and first 5 rows for the testing set. Yeah. Then we printed the length of our training set. Now for the logistic regression. So first, what we did was we described our independent feature, which is x, all the rows and columns from 12 to last. So 12 to last means we are including rows with our standard values only for the train set, and for the testing set, it is okay. So the x values are the same. For the target variable, we are only going to print whether a wine is good or bad, which means we are going to print the values of 11th column, that is 0 for the bad quality one and 1 for the red quality one. And then we printed the shape of our training and testing. Then we made a transpose of our x train, which is we converted our x number of rows into matrix and made a transpose of that. So now we have one additional column, which means we have total 119 rows and 12 columns. Since we made a transpose, the rows and number of columns are interchanged in this one. For this, first we are going to calculate our cost function, and then we'll calculate the value of our theta. So the number of iterations, there are 50,000 number of iterations. That means we are going to do this for 50,000 sets. And then we set our learning rate to 0.005, which depends upon how many number of iterations we are going to do. Then we created an empty list to append the values of cost functions after each iterations 50,000 times. Now here we have our hypothesis function, which is a size of 1 by 1,119. So for that, we transpose our theta value and did matrix multiplication with our augmented x train value. Then we wrote the equation for our sigmoid function, which this prints the value only 0 and 1. So we need there are various false prediction made by our model. So the function of cost function is to predict those values, predict the wrong predictions. So if our model predicts bad wine as a good wine, like if the wrong prediction is good, we use this function to find the cost function. And if it wrongly predicts our value to be bad, so we use this function to find our total cost function. So the formula for our final cost function would be 1 divided by length of the training set times sum of FT and ST, which means the wrong predictions of good and bad.
Then we appended this cost function to our empty list cost function. And then we calculated the derivative of our cost function by this given formula. Then we update the values of our theta. And at last, we printed the length of our cost function. So we predicted the value of y. For prediction, we did metric multiplication of transpose of theta and x-train augmented. So x-train augmented is the transpose matrix of our x-train. So we did matrix multiplication for this, and then we, according to our sigmoid function, as I mentioned, if the quality is greater than 0.5, it will print good, which is given by 1, and if not, if it is less than 0.5, it will predict as 0. So this is then we did the graphical representation showing the relation between our cost function and number of iterations. As we can see, higher the number of iterations, lower the value of cost functions, which means if we train our model for many number of times, we have high chance of getting lower cost function, which means we have high chance of increasing our accuracy by decreasing the number of wrong predictions. And yeah, then we did the evaluation of our training and testing set by counting number of true positive and true negatives, false positive and false negative.
Okay, so for the logistic regression, we first implemented many modules from the sklearn module or library. So first we have selecting different parameters from the data frame as dependent and independent variables. So all of our wine characteristics or qualities are presented as our X variable, and then the quality check, the binary quality check output as Y. The changing the features into the standard unit, there's a function in the sklearn library that converts into standard units. That's what this does right here. We splitting our data frame into training, 70% training and 30% testing, like we said. Splitting our independent X and Y into 2 different training and testing sets. Then we printed the length of each one right here, as it says 1119 for the training set and a 1480 number of rows for the testing set. And then we trained a model for the red wine quality prediction. So this is a logistic regression classifier object, which used the logistic regression function. So this is the regression model from the X and Y variables that we stated above. And this has 50,000 iterations on it as well. And so this is the testing of the model. This is the testing set right here as printed in the binary output for the quality check. This is the quality check being outputted. And then the model evaluation on both training and testing set. This is the classification report for the Y variables and the confusion matrix for the Y variables as well. And so the confusion matrix evaluation metrics, which includes accuracy, precision, recall, and F1 score. Right here, it's printing the accuracy of the model.
So this is the project management of our red wine quality prediction project. So what we did overall was we did some data analysis on the given CSV file. We did some graphical representation, and we made a new data frame which included only the required parameters to predict the quality of our wine. So our major task was just to print whether the quality of wine is good or bad. We didn't have much to do with our quality score, so we removed that quality score factor. We then trained our module. Our module contained 70% of our training and testing set, and after training our module, we predicted the value, we predicted the Y values, we checked the precision, we calculated the precision, recall, F1 score of our predicted module. So the individual responsibilities of each group member will be described by themselves.
I worked on the acquisition of the given data of wine quality, and then analysis of the database and explaining the words, so explaining how it works and proofreading the notebook.
And I was responsible for implementing the logistics regression using the Scikit library. Also was responsible for running the error testing and testing the code, and there was no errors found in the code, so that was my part.
Okay, so for me, my part of job was to implement the logistic regression from scratch. So using gradient descent algorithm. So I also built the predictive model for the user input. We did have some errors while implementing the gradient descent algorithm, but we were successful to overcome those mistakes and run our code successfully.